Now let's get back to our data set and mark these two values. One comes somewhere here, minus 35. The second one, upper bound, comes somewhere here, which is 77. Any value beyond this, like lesser than minus 35 and more than 77 for this particular data set, which is minus 44 and plus 90, are outliers for this particular data set. Hello everyone. In this episode, we'll be focusing on outliers. As part of data processing in machine learning journey, we have to take care of many of the steps. One of the important point is to handle the outliers. So what are the outliers by definition? By definition, an outlier is an observation in a data set which is lying abnormally away from the general population. But in a more statistical or more technical definition is like this: a point way beyond from quartile 1 and quartile 3. When we say way beyond, it is more than 1.5 times the interquartile range from quartile 1 and quartile 3. Too much of technical details. Let's get back to it, each one of these terms in the next slide. But to understand more pictorially, you can watch this. So there is one particular point here. This is an outlier. All these points are following a pattern and this is not following a pattern. Again, in this bar chart, there are so many values for each and every person. Most of the values are below 8. There is one person, Jane, whose number is like way beyond. It's 24. This is an outlier. Now let's try to understand more technical terms like interquartile range, quartile 1, quartile 3, all these things. So to understand these interquartile range, quartile 1 and 3, quartile 2, median, everything, we need to have some sample data sets. So let us find some sample data set. So these are 11 points. This is our data set for our understanding purpose. So what do we do? What is the process to find the interquartile range, quartile 1 and 2 and 3? So first of all, we need to sort the values in an ascending order and we need to apply the formula. The formula is Qi is equal to I multiplied by n plus 1 divided by 4th term, where I is nothing but 1, 2, 3. I is 1 means first quartile, I is equal to 2 is second quartile, I is equal to 3 is third quartile. And n is the number of samples, which is 11 in our case. Now, interquartile range is nothing but the value of quartile 3 minus value of quartile 1. So let's start by sorting the values. So we are going one by one. There are 11 positions and each and every data is getting sorted ascending order. So once this is done, we need to apply the formula. And the formula is Q1 is equal to 1 multiplied by 11 plus 1 divided by 4 for quartile 1. By solving this, we will get the third term. So the third term, this is first term, second term and the third term. And third term is nothing but 7. And that is our quartile 1. Similarly, quartile 2 is nothing but 2 multiplied by 11 plus 1 divided by 4, which is 24 by 4, which is 6th term, which is nothing but 1, 2, 3, 4, 5, 6. This is the one. Value is 12. Similarly, quartile 3 is equal to 3 multiplied by 11 plus 1 divided by 4, 36 by 4th term, which is 9th term. So the 9th term is nothing but 35. Okay, now we need to find the interquartile range, which is nothing but 35 minus 7, which is nothing but 28. This is our interquartile range. So quartile 2, which is 12, is also called as median of this particular data set. Median is nothing but if you sort the values, whichever is in the middle point, that is our median. So you can also understand the quartile 1 is the median of the first half of the data set, and the quartile 3 is the median of the second half of the data set, which is 35 here and 7 here. So quartile 1 is 7, quartile 2 is 12, which is also called as median, quartile 3 is 35. Now let's move ahead and try to understand how to find out the outliers based on these three values. So to understand definition of outliers, which is nothing but 1.5 times the interquartile range from quartile 1 and quartile 3. So we need to find lower bound and upper bound. Lower bound is nothing but Q1 minus 1.5 times the interquartile range, which is 7, which is Q1 7 minus 1.5 times interquartile range, which is 28, which comes to minus 35. Similarly, the upper bound is nothing but Q3 plus 1.5 times the interquartile range. Q3 is nothing but 35 plus 1.5 times the 28, which is 77. These two are lower bound and upper bound. We have found them. Now let's get back to our data set and mark these two values. One comes somewhere here, minus 35. The second one, upper bound, comes somewhere here, which is 77. Any value beyond this, like lesser than minus 35 and more than 77 for this particular data set, which is minus 44 and plus 90, are outliers for this particular data set. The same information can be plotted using a graph called as box plot. So let's try to understand. Let's go back to our number line, and in this number line we can put the box, and the box will have a line inside it. So if you want to understand the box plot, we will have the Q1, which is somewhere on the left hand side of the box, which is the first quartile. Q2, which is the median. If you see 12, the median of this value is 12, so that's why I marked somewhere near 12. Q1 is 7, so we have marked the box, started the box somewhere near 7, and Q3 is 35. You can see it is near 35. Now, how do we mark the lower bound and upper bound? We are doing it by using two wicks. The wicks are, the line, extended line from the box, which is telling this is the lower bound and this is the upper bound. Any point in between this lower and upper bound is okay, and any point beyond these two, like 40, minus 44 and plus 90, they are the outliers. And in the next episode, we will try to understand how to deal with outliers, what to do with that in our dataset before moving into any machine learning models. Thank you for watching. Bye-bye.